All right, this is your quiz from Friday, January 16th. You'll find the quiz, if you don't have it, in the description of the video with the solutions. So let's go over this. This says the arc sine of 1/2. So inverse trig functions like arc sine output angles. So the answer to A, B, C, all these inverse trig functions have to be angles. So I'm drawing a unit circle right here. And since this is arc sine, this represents a y coordinate on the unit circle. So I know this point right here in blue has a y coordinate of 1/2, and so does this point over here in red. So it's going up 1/2 unit on the y-axis, and we should hopefully know this point square root of 3 over 2 comma half, and that's negative square root of 3 over 2 comma half. Now arc sine must output an angle in between and including negative pi to positive pi over 2. So negative pi to pi over 2. So our answer will be pi over 6. That's that angle in blue. The sine of pi over 6 is 1/2. Again, this is the inverse of cosine. The answer should be an angle. This input represents an x-coordinate on the unit circle. So there's a point right here with an x-coordinate of negative rad 3 over 2, and one right here as well. Now, our cosine must output an angle between 0 and pi. So our solution to this problem must be 5 pi over 6. The cosine of 5 pi over 6 is negative square root of 3 over 2. Arctangent of negative square root of 3. So again, this is a unit circle I've drawn. Since this is arctangent, negative square root of 3 represents a slope of an angle. So I'm going to draw an angle here with a slope of negative square root of 3. And there's another angle here with the slope of negative square root of 3. Now, similar to arc sine, arctangent has to also output angles between negative pi over 2 and positive pi over 2. So it's this angle in blue. Now, I can't say that that angle right there is 5 pi over 3. It is true that the tangent of 5 pi over 3 is negative square root of 3, but again, the arctangent has to output an angle between negative pi over 2 and positive pi over 2. So starting at 0 here, the answer is going to be negative pi over 3. Arc sine of 1. So arc sine of 1, the answer is going to be an angle. Because this is arc sine, this value that's inputted, this 1 here, represents a y coordinate on the unit circle. This point here is 0, comma 1. That's the only place on the unit circle with a y value of 1. And so starting at 0 here, if I go this direction counterclockwise, that angle is pi over 2. The sine of pi over 2 should equal this 1. Part E. It's another inverse trig function, so the answer, the output, better be an angle. This input represents an x-coordinate on the unit circle. That x-coordinate is negative 1. This is the only point on the unit circle that has an x-coordinate of negative 1. The outputs of arc cosine must be between or including 0 to pi. So that angle in red is pi. Arctangent of 1. So I'm going to draw an angle, or draw angles with a slope of 1. This is like the line y equals x has a slope of 1. Arctangent must output an angle in between negative pi over 2 and pi over 2. So this angle in blue is pi over 4. The tangent to pi over 4 is equal to 1. All of these are inverse trig functions, so each input has exactly one output. Now, in part G and H, I can see that I have sine here, and this will be sine. You take the sine of angles, so this arctangent will output an angle, and the sine of this angle will represent the y coordinate where this angle intersects the unit circle. So I'm familiar with this slope. It's the same as 1 over the square root of 3. So 1 over square root of 3, if you rationalize this denominator and multiply by square root of 3 over square root of 3 to rationalize the denominator, you would get rad 3 over 3. So we're more familiar, my students are more familiar with the slope 1 over square root of 3. But it's the same as that value there. So I'm going to draw the angles that have a slope of square root of 3 over 3. Oops, I'm going to make this a different color. So arctangent of square root of 3 over 3 will be the angle in the first quadrant. The outputs of arctangent have to be in between or including negative pi to pi over 2. So this will be pi over 6. So this problem is equal to the sine. So you have sine right here, sine. And we just figured out that arctangent of square root of 3 over 3 is pi over 6. Now you technically don't have to write this down, sine of pi over 6, the pi over 6 part. We just have to identify this angle here is one that we're familiar with. And it intersects the unit circle at the square root of 3 over 2. The square root of 3 over 2, comma a half. And the sine of this angle will be the y coordinate where the angle intersects the unit circle. So the sine of this angle, pi over 6, is 1/2. So that's our solution to this expression here. It was a bummer that some people had angles for their final answer, and that's not going to be true because you take sine of angles. And so this better be, the output of sine better be a value in between or including -1 to 1. Remember, sine goes up to 1 and down to -1. So that's the range of sine, -1 to 1. So your output for sine of an angle better be in between or including -1 to 1. The answer to this will not be an angle. Similarly, part H, arc sine of this value will output an angle. And then you take the cosine of that angle, and the cosine of the angle will represent an x-coordinate on the unit circle. So let's try to figure out where this angle arc sine of negative square root of 3 over 2 is. So here's my unit circle. There's a y value of negative square root of 3 over 2 right there. It's going over to the half, down negative square root of 3 over 2. Technically, there's another point over here that also has a y value of negative square root of 3 over 2. Arc sine, again, has to be an angle between or including negative pi over 2 to positive pi over 2. So I think we actually solved this problem up here, didn't we? Oh, nope. So arc sine of this angle is going to be negative pi over 3. You don't actually have to write negative pi over 3 here, but this is equal to negative pi over 3. All I want to know is what's cosine of that blue angle? What's the x-coordinate here? And it's a half. Maybe you could have already concluded that if the y-coordinate where the angle intersects the unit circle is negative square root of 3 over 2, the x-coordinate would be either a half or negative a half. But because arc sine has to be in the first or fourth quadrant, we know cosine of those angles must be positive, since all of these x-coordinates of points in the first and fourth quadrant have to have positive x-coordinates. Okay, now some of my friends thought that this answer was negative pi over 6. That's a bummer, because arc cosine has to output a value between 0 and pi. And so negative pi over 6, well, that's less than 0. That's left of 0 number line. So unfortunately, if you said negative pi over 6, that's wrong. This answer will equal an angle, for sure. Cosine of this angle is an x-coordinate, and then arc cosine of that value is an angle, but this angle must be in between or including 0 to pi. It's going to be somewhere in there. So we can focus on this cosine of negative pi over 6. I'm going to draw the angle negative pi over 6. It's right here. Now the cosine of this angle represents this x coordinate of where the angle intersects the circle. This point we should be familiar with. It's square root of 3 over 2, comma. I honestly really don't care what that y value is because the cosine of this angle is the x coordinate. And so this is equal to the arc cosine of square root of 3 over 2. So this part I highlighted is like chapter 5 of our textbook. We're just evaluating trig functions of angles. And then this is chapter 6 in our textbook. We're taking the arc cosine. And now, besides this point in blue, there's another one right up here that also has an x coordinate of square root of 3 over 2. And since arc cosine has to output an angle between 0 and pi, the answer will be this angle in red, which will be pi over 6. All right, some peeps thought that the arc tangent would undo each other because they're inverses, and they put 2 pi over 3 for their answer. Well, the output for arc tangent has to be in between negative pi over 2 to positive pi over 2. And 2/3 pi, that's over here. That's past pi over 2. So the answer to this problem won't be 2 pi over 3. If we do evaluate the tangent of 2 pi over 3, I would draw that angle 2/3 pi. It's right here in the second quadrant. Now the slope of this angle is negative square root of 3. This point, the coordinates of that point, are negative a half, so negative a half, comma rad 3 over 2. When some people see tangent, they have to take the tangent angle by taking the y divided by the x, and you would see that when you divide these, square root of 3 over 2 divided by negative a half, you would multiply by the reciprocal and the 2's would cancel and you'd be left with negative square root of 3. You technically don't even have to know what this value is. What you need to do is you have to draw the other angle or angles that have that slope. I say angles because it looks like I've drawn 2 here. But technically, this angle in blue could be 5/3 pi. It could be negative pi over 3. If I subtract 2 pi from negative pi over 3, I go all the way around full circle, and I'm there again. But in between, the arctangent has to be in between negative pi over 2. So here's 0, negative pi over 2 to pi over 2. So this angle in blue is going to be negative pi over 3. So in review, whenever you have the arc sine, arc cosine, arc tangent, the inverse function of something else, so every question except part G and H, the answer better be an angle. In G and H, you had sine of the arctangent, cosine of the arcsine. So sine of an angle has to output a value in between negative 1 or 1, or including those values. Same with cosine. Cosine function, it looks very similar to sine. It only goes up to 1 as the max, and the min is negative 1. Okay, so question 2 is review. Now, my students are doing super well at condensing this using the quotient property for logarithms. You see a logarithm, natural log, the base is e, these have the same base, so we condense these using the quotient rule. This problem's been on the last few quizzes because as a class our scores have been under 80%. Now I'm going to keep this right side 4. The natural log of a function, natural log function, its inverse is an exponential function with base e. So I'm going to take base e at both sides, and I get x over x minus 5 equals e to the 4th. Now the rest of this is actually algebra 1. That's kind of what we're stumbling with right now. The goal is to solve for x, but I have an x in the numerator and then I have an x minus 5 in the denominator. So the process is to get at least both x's, the terms with x's, both in the numerator. So my first step is going to be to multiply both sides by x minus 5. So if I multiply the left side of the equation by x minus 5, that'll cancel here. If I multiply the right side by x minus 5, I'll have that here. So this was what I was hoping for. I was hoping to have x in the numerator, both in the numerator, instead of having the denominator here. Now I want to get these terms with the x's on the same side of the equation. It's like they were a moment ago, but both in the numerator. So I have to first distribute e to the fourth. E to the fourth is just some number. It's like 2.7 approximately to the fourth power. So I'm just going to distribute that. So we get x equals e to the fourth times x minus, distribute e to the fourth to that minus 5. That's 5 e to the fourth. Okay, now I want to get these terms with the x's on the same side of the equation. And so I'm going to subtract e to the fourth times x to both sides of the equation. So I just subtracted this term to both sides. And now we have a common factor of x. So I'm going to factor out x, and I get x times 1 minus e to the fourth. X times 1 is x, that checks out. X times negative e to the fourth is this term here. So this says x times this number here. So I'm going to divide both sides of the equation by 1 minus e to the fourth. Now in my solutions, I have 5 e to the fourth divided by e to the fourth minus 1. What I had done when I solved this was I actually subtracted x to both sides and then added 5 e to the fourth to both sides. And then I ended up solving for x, but these are the same. If you multiply the numerator and denominator both by -1, you get this solution here. Now I am a little concerned. I have to make sure that the value for x, the natural log of a negative, is undefined. And so I need x to be bigger than 5, because if x is 4, 4 minus 5 is -1, and the natural log of that's undefined. What happened here is when we condense this, the domain actually changed between this equation and this one. So a negative over negative does equal a positive, but individually a natural log of a negative would have been undefined. So I am concerned about having an extraneous solution. So what we think is our only solution is this value here. And this value will be bigger than 5, so it will be a solution. 5 e to the fourth divided by e to the fourth would be 5. But we're actually dividing by a smaller number, e to the fourth minus 1, so this will be bigger than 5. All right, so now we have a test coming up this week, and question 3. Problems like this, graphing the 6 trig functions, will be on your test. So we want to make sure we know these very well before our exam this week. Okay, so it's kind of blurry here. We'll just have to deal with it. The quiz is in the description, or if you have it with you. Now, I'm going to show you how to do this problem 2 different ways. So the first way is you just graph 3 times sine of 2x. So we know sine of 0 is 0. The function's increasing to the right of 0 initially and then decreasing. The relative max of sine is 1. Sine of 2x, the biggest output it can have is 1. But then we have a times 3 here. So now 3 is the biggest output this function can give us. And -3 is the smallest output. Normally, this is pi. The sine of pi is 0. But this is a horizontal compression. you're going to take the parent function sine of x and you're going to divide all the points by 2. Not multiply by 2, but divide by 2. So this is going to become pi over 2 here. This x-intercept is normally pi for sine of x, but you're going to divide, oops, I'm sorry, this one is normally 2 pi. This one's pi. This one's 2 pi. So we're going to divide by 2, so that becomes pi. Okay. Now, one other thing, we should know the period of this function is equal to the absolute value of 2 pi divided by the coefficient of x. And so the coefficient of x is 2. So I'm dividing 2 pi by this orange 2 right here, and we get pi. So if I start here at the origin, this is a complete period, which is pi. From the x-intercept to x-intercept will be half a period, so that checks out. From this x-intercept to that x-intercept is pi over 2. Now I could draw more of this graph, and this x-intercept over here would be negative pi over 2. Okay, now we have to shift this graph, and a lot of students initially want to say that we're shifting this graph to the right pi over 2, but pi over 2 isn't the value for x that will make this 0. If you set 2x minus pi over 2, if you set this equal to 0, you can add pi over 2 to both sides, divide by 2, you get positive pi over 4. This is our shift. Okay, or if you wanted to, I don't think you want to, but you could factor out a 2. So I think we prefer this option here, where you set this 2x minus pi over 2 equal to 0. You solve for x, and that's your shift. Otherwise, you factor out 2. 2 times x is 2x, check. 2 times pi over 4 is pi over 2. Okay, so we have to shift this graph to the right pi over 4. See this point at the origin, 0, 0? If I shift that point at the origin, I'm going to put a little star here. Make it purple and put a star. If I shift that to the right pi over 4, that purple point will be right here. Now, negative pi over 2, if I shift that to the right pi over 4, negative pi over 2 plus pi over 4 will be negative pi over 4. So these x-intercepts are the same distance away from the y-axis. Now see this orange and purple point? I hope the color shows the same on the video, but in between these 2 points, the curve is beneath the x-axis. So between these 2 points, the curve is beneath the x-axis. This means the y-intercept should be at negative 3, because this distance these 2 x-intercepts are from the y-axis is the same. Now the graph's going to go up to 3 and back down. That's one period I have drawn. Now, the x-intercept, see these 2 x-intercepts? This is pi over 4 and this is pi over 4. That's a distance of 2 pi over 4. So x-intercept to x-intercept will be 2 pi over 4 apart. So pi over 4, I add 2 pi over 4 again. That becomes 3 pi over 4. If I add 2 pi over 4 again, I get 5 pi over 4. I'm saying add 2 pi over 4, and I hope you know it reduces to pi over 2. And if the period is pi, the x-intercept should be half a period apart, so pi over 2 apart. Now, I have 1.5 periods drawn, and the directions say when graphing trigonometric functions, graph at least 2 periods of the function, label the intercepts. If there's any asymptotes, label those. and label the relative max and min values on the y-axis. And so that's what I'm doing right here when I've labeled -3 here. I've labeled the relative min. The relative max is 3. I really want this graph to go up to that, and it looks like I have it not quite as high there, so I'm just going to relabel this at 3 right here. And I need to draw one more of these in order to get 2 periods, at least 2 periods drawn. And there's arrows at the end. It continues on forever and ever. So again, this is 2 power 4 apart from intercept to intercept. So negative pi over 4, take away 2 power 4 would be -3 pi over 4. All right. I told you I was going to show you 2 ways of doing this problem. Here's what I do. I actually don't do it that way. What I do is a little bit quicker, especially for the result we're going to have here. What I do is I plug in 0 for x to find the y-intercept. And then I figure out that sine of negative pi over 2 is -1. So sine of negative pi over 2 is -1 times 3 is -3. So I'm actually going to erase all this and show you an alternative way of doing this problem. That you might like better. So I was saying I'm going to find the y-intercept first. So y equals 3 times the sine. I plug in 0 for x, so I get 0 minus pi over 2. This is 3 times sine of negative pi over 2. So that's 3 times -1 is -3. So I'm going to put a point on the y-axis at -3. Now, I know that's the minimum value of this curve, the relative min. So the graph from the right has to increase. That's our only option. It must go up from there. And we know the relative max is 3. We're going to go down and back up. Now that's a whole period I have drawn there. I'm going to go this direction. So even though this is a sine function with a shift and a change in the period and an output stretch, it actually looks like the cosine function. So for cosine, this first x-intercept, because this graph's symmetric to the y-axis, is normally pi over 2. But the period changed, so I'm going to divide, not multiply by 2. I'm going to do the inverse of this. I'm going to divide by 2. So if this is normally pi over 2, I'm going to divide by 2, and that becomes pi over 4. This x-intercept is normally negative pi over 2 for the cosine function. And now when we divide by 2, it becomes negative pi over 4. This x-intercept for cosine is normally 3 pi over 2. But we divide by 2, we get 3 pi over 4. And similarly, this is -3 pi over 2, divided by 2 is -3 pi over 4. Okay, 3b. Just like the previous problem, I'm going to do this 2 different ways. So we have 3 cosine of 4x plus pi. I'm going to graph the function with the change in the period, that 4x part, and the 3. I'm going to deal with the shift left and right in just a moment. So the cosine function, the cosine of 0 is 1 times 3 is 3, so it has a y-intercept. This function has a y-intercept at the relative max. The graph must be decreasing from there and going back up. This first x-intercept to the right of the x-axis is normally pi over 2 for cosine of x. It's pi over 2. That's the parent function, cosine of x, that'd be pi over 2. But now this says you have to take all of the x coordinates of the cosine of x function and you divide them by 4. And so this pi over 2, when we divide by 4, becomes pi over 8. This point here, this x-intercept, is normally 3 pi over 2 for the cosine of x function. But you divide by 4, it becomes 3 pi over 8. This graph is symmetric to the y-axis. So these values are just the opposites of the one on the right side. All right, now you're going to get in trouble if you say the shift is left pi units. That's going to be a really popular answer. You see a plus pi there. Sure, if it was not 4x but 1x plus pi, yeah, for sure we're going left pi. But we're going to shift this function to the left pi over 4. How am I getting that? I'm looking at 4x plus pi. I'm imagining when that will equal 0. If I subtract pi to both sides and then divide by 4, I can see that shift is left pi over 4 units. So this is 0 right here, 0, 0. This is pi over 8. Right here, if this is pi over 8, right here in the middle would have to be 2 pi over 8, which would reduce to pi over 4. So what I'm suggesting is that this point is pi over 4, comma, negative 3. See, if from here to here is pi over 8, and this distance is pi over 8 again, this is 2 pi over 8 to get here. Add pi over 8 again, that's 3 pi over 8. It's all checking out. So if I'm shifting this graph left pi over 4, this point in purple, I hope it's purple for you guys, when I shift it left pi over 4, it's going to be right there. So that point in purple is right there. Okay, I want these relative max to be at the same height. It doesn't look like it's, oops, the same height. So let me try to fix that. There we go, it's better. All right, I'll put arrows here at the end. Goes on forever. I have 2 periods drawn here. I want you to label the relative max on the and the relative min on the y-axis. So this x-intercept is normally pi over 2. Divide by 4, it's pi over 8. Otherwise, you could take this 3 pi over 8, shift it left pi over 4, and then it would become pi over 8. This graph is symmetric to the y-axis, so from the origin to the left here will also be a distance of pi over 8, but I'm going to label this negative pi over 8. If you took this point here, pi over 8, 0, and you shifted left pi over 4, it'd become negative pi over 8. You could also use the fact that the period of this function is the absolute value of 2 pi over 4. So that's pi over 2. Half the period is half of pi over 2, which is pi over 4, which is the same number as 2 pi over 8. If I multiply pi over 4 by 2 over 2, I get 2 pi over 8. So the x-intercepts are half a period apart. So negative pi over 8 plus 2 pi over 8 is 1 pi over 8. Add 2 pi over 8 to that, you get 3 pi over 8. Take away 2 pi over 8 from negative pi over 8, you get negative 3 pi over 8. All right, the alternative, the other way of doing this problem is how I did part A. I'll just briefly explain. You plug in 0 for x first to find the y-intercept. So you get the cosine of pi. So here's the angle pi. The cosine of that angle is negative 1 times 3 is negative 3. So then we know the graph has a y-intercept of negative 3. And so just like the previous problem, the graph has to increase initially from the right and then go back down. And we can sketch the curve. Now this x-intercept for cosine, because it looks like the cosine function with the reflection across the x-axis, this is normally pi over 2, divided by 4 is pi over 8. This x-intercept is normally 3 pi over 2, divided by 4 is 3 pi over 8. And these are just symmetric to the y-axis. All right. Let's go ahead and graph y equals secant of 3x. Oops. So this is 3c. Oh, there we go. It's right here. So the cosine of 0 is 1. And I'm saying that because cosine is the reciprocal of secant. So if the cosine of 0 is 1, that means when you plug in 0 here, the secant of 0 will also be 1 because the reciprocal of 1 is 1. I'm going to label this 1. Now, this parent function for secant, this first asymptote to the right of the y-axis is normally pi over 2 because the cosine of pi over 2 is 0. And so the secant of pi over 2, when you take the reciprocal of 0, you're dividing by 0 now, so it's undefined. So this is normally pi over 2 for the parent function. But you have to divide all of the x coordinates of the points and the asymptotes by 3. And so this becomes pi over 6. This asymptote is normally negative pi over 2 for the secant function. Divide by 3, it's negative pi over 6. So here's my other curve. I'm going to label, like the directions say, the relative min and max on the y-axis. Now, normally, this x-intercept, no, not x-intercept, well, I guess it's an x-intercept for cosine. That's normally 3 pi over 2. The graph goes down here and then back up at 3 pi over 2. So that x-intercept for cosine becomes the asymptote for secant. So 3 pi over 2 divided by this 3 is pi over 2. Now I have 1.5 periods drawn, so I need to draw another period. So I'm going to go to the right. And I know the curve will be above the x-axis right here. Now check this out, it's pretty cool. From here to here is pi over 6. This is another pi over 6. So pi over 6 plus pi over 6 again is 2 pi over 6. Add pi over 6 again to go from here to here. That's 3 pi over 6, which is pi over 2. 4 pi over 6, 5 pi over 6. So again, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. The period of this function is 2 pi divided by this coefficient of x. So it's 2 pi over 3. All right. Part D. Now the cotangent of x, here's the parent function. The tangent of 0 is 0, so the cotangent of 0 will be undefined. There'll be an asymptote right here. This is what the parent function looks like. From asymptote to asymptote's a full period for the cotangent and tangent functions. So from 0 to pi, the period of this function is pi divided by, it's the ops value of pi divided by the coefficient of x. So this coefficient is a 1 here, so the period is pi. Now we're going to shift this graph left 3 pi over 4. So we're shifting the parent function left 3 pi over 4. If you don't see it, you have to set this binomial equal to 0 and subtract 3 pi over 4 to both sides. So now normally I wouldn't have graphed the parent function. I know that cotangent has an asymptote at the y-axis, and I just shift it left 3 pi over 4. And then I could just use the fact that from asymptote to asymptote, it's a pi apart in this problem. So pi to the right, if I add 4/4 pi, I get pi over 4. Now, if I add pi again to power 4, because the period is pi, so if I add pi over 4 plus 4/4 pi, I get 5/4 pi. So the asymptotes are a full period apart. Now, in the middle of these two asymptotes is the x-intercept here. So if I want to find the middle number or the average, I just add up power 4 plus 5 power 4 is 6 power 4. So these two numbers combine to 6 power 4 when I add them. That's 3 pi over 2. But if I'm finding the average, I have to divide that by 2, which becomes 3 pi over 4. It makes sense that this is power 4 here, this asymptote. And if I go 2 power 4 to the right, I get this x-intercept. 2 power 4 to the right more, I get 5 power 4. So these intercepts are also pi apart. So if I go pi to the left, that's negative pi over 4. So again, I was noticing that this is 2/4 pi apart. So this should be 2/4 pi apart. So power 4 minus 2/4 pi is this here. Now the directions say to label your y-intercept, so we have to find this y-intercept here. So I'm going to plug in 0 for x. I get the cotangent of 3 power 4. So that's going to be the reciprocal of tangent to power 4, 3 power 4. So I'm thinking, hey, what's tangent of 3 power 4? That's -1. And so cotangent is the reciprocal of that. So that'll also be -1. So that's our graph. All right. Just to save time here, if you don't mind, tangent of x, the parent function, has a point at the origin. And the curve goes up like that. It's increasing. And so I'm going to shift tangent of x to the right, pi over 6. If you set this equal to 0 and you add pi over 6, you see it's shifted right pi over 6. So the x-intercept that was at the origin is going to be to the right of the origin, pi over 6. I'm going to sketch my curve here. Now normally this x-intercept for the parent function is pi over 2. So if I go to pi over 2 here and I add pi over 6 or shift, this angle here is 2/3 pi. Otherwise, you have to write down pi over 2 plus pi over 6, create a common denominator, combine those terms, it'll reduce to 2 pi over 3. The period of this function tangent is pi divided by the coefficient of x, so it's pi, the period's pi. Asymptote to asymptote is a period apart. So I'm going to go left pi from 2/3 pi, and that gives us negative pi over 3. Now you have to draw at least 2 periods, so I'm going to just go right. I'm going to add pi. 3/3 pi is pi, 3/3 pi. So I'm going to add 3/3 pi to 2/3 pi, and that's 5/3 pi. Now the x-intercepts are also pi apart. So if this is 1/6 pi, and I add 6/6 pi, which is just 1 pi, so 1/6 pi plus 6/6 pi, that's 7 pi over 6. Now we have this y-intercept here. So to find the y-intercept, we know this point is 0, comma, some negative y coordinates. So we're going to plug in 0 for x. So we have y equals tangent. I'm going to plug in 0 for x, so I get negative pi over 6. So I'm thinking, okay, here's the angle negative pi over 6. We should know that the slope of that angle is -1 over the square root of 3. Some people will call that negative square root of 3 over 3. I prefer just to call it -1 over square root of 3 and not rationalize the denominator. So if you didn't know that slope, you'd have to take these coordinates, rad 3 over 2, comma -1/2. And the tangent of this angle is the y over the x, the opposite over the adjacent. And this would reduce to -1 over rad 3. All right, we're almost there. Part F. It's not showing up, so let me just write it down here. All right, so I already graphed the parent function for cotangent earlier. It has the vertical asymptote here at the y-axis. And the graph is not being shifted left or right at all, so the asymptote will stay at the y-axis. Now this 1/4 x is actually an input stretch. Cotangent of x has an asymptote at pi, but now we're not going to divide all the points and the asymptotes, those values, by 4. We're going to do the inverse. We're going to multiply by 4. So this was normally pi, now it's going to be 4 pi. This is negative 4 pi. Remember, the period for tangent and cotangent is pi, the absolute value of pi, divided by 1/4. I'm sorry, it's pi divided by the coefficient of x, which is 1/4. And that's pi times the reciprocal of 1/4, which is pi times 4. So the period is 4 pi. So from asymptote to asymptote, it's a full period. In the middle of these asymptotes are your x-intercepts. So this will be 2 pi. Normally, the cotangent function looks like this. But because of that negative, it's going to be a reflection across the x-axis. So this part that was above right here is now reflected below the x-axis. This part that came down beneath the x-axis is now above. Now this the 2 part, that 2 times is going to stretch the graph vertically. It's hard for me to show that since the range of this is all reals. It's not like the sine and cosine functions where we change the relative max and min and we can see it really being stretched up. It's hard to see because the range is all reals in this function. All right, so that is our graph. The x-intercepts should be a period apart. This distance is 2 pi, this is 2 pi, so from here to here is a total of 4 pi, which is the period. All right, domain. The natural log of 0 is undefined, so we don't want this argument to be 0. The natural log of a negative is undefined, so we need 3x squared plus 5x minus 2 to be positive. I just factor this using deductive reasoning, but I'm going to show you the diamond method. What number is multiplied at negative 6? I get that from 3 times negative 2 and add to 5x. Whoops, or I should say 5. And that's going to be 6 and negative 1. So 6 times negative 1 multiplies negative 6 and adds to 5. The purpose of doing this diamond is to rewrite this middle term 5x, and now I promise you, I guarantee this problem will be factorable by grouping. So 3x squared plus 6x minus 1x minus 2 is greater than 0. So see this 6 and this negative 1? I rewrote 5x as 6x minus 1x. So this inequality here is the same as what's above here. Just these two terms are written a little bit differently than that one. Now I'm going to underline the first 2 terms and the last 2 terms. I'm going to factor out the GCF of the first 2 terms, which is 3x. I'm left with x plus 2. 3x times x is 3x squared. 3x times 2 is 6x. I'm going to factor out negative 1. Now, as long as I got these numbers correct, in this step right here, these binomials I'm underlining in dark blue better be the same or you made a mistake, either in factoring or these actually weren't the numbers that make the statement true here. So I'm going to factor out that common factor, x plus 2, that's underlined in blue. After I factor that out, I'm left with 3x minus 1. Now I'm going to solve this by graphing the polynomial. If I set this equal to y, You'd have x-intercepts at -2 and 1/3. The leading coefficient is 3. The leading term is 3x squared, so the graph is going upwards. So I can see the graph is above the x-axis. From -infinity to -2, and from 1/3 to infinity. That's when the outputs will be greater than 0. If I plug a number in less than -2 in for x, this factor would be a negative, and that will be a negative. And a negative times a negative is a positive. If I pick a number to the right of 1/3 and plug it in here, this factor will be positive, and this factor will be positive. And a positive times a positive is a positive. So I want you, it says in the directions, to write your answers to problems involving domain and interval notation. All right. 5b. So the square root, unlike the natural logarithm or logarithm, the square root of 0 is 0. The log of 0 or natural log of 0 is undefined. So here, if I have the square root of 0, there will be an output. So I'm going to set this argument. I need it to be greater than 0. I need it to be positive because you have to take the square root of positives over the real number set, or it could be equal to 0. Now, even though this is not a polynomial, I'm going to graph the polynomial. Because I could graph this rational function and figure out when it's above the x-axis, but a negative over a negative, the sign of that is positive. And the same with the product. A negative and a negative, when multiplied together, is also positive. So if I set this graph equal to y here, it'll be above the x-axis for the same values of x that this polynomial is. So my preference is to draw the polynomial. The zeros are -4 and 2. And just like the last problem, the leading coefficient is x squared here. So the graph is above the x-axis from -infinity to -4, union 2 to infinity. Now, as I write my solution, I'm going to decide, should I put a bracket on -4? And the answer is no. If I plug in -4 for x, I get -6 divided by 0, which is undefined. So this needs to be a parenthesis here. Union, I'm going to put a bracket on 2. Because if I plug in 2, I get 0 divided by 6, which is 0. And the square root of 0 is 0. So it's 2 to infinity. So -infinity to -4, union 2 to infinity. All right, last problem. It says rewrite this expression as a number given log of a equals 2 and log of b equals 3. So I'm going to go ahead and just take that squared outside of this and rewrite this as a to the 4th times b squared. Now I'm going to use the product property of logarithms and expand this as log of a to the 4th plus log of b squared. I'm going to use the power property. This becomes 4 log of a plus 2 log of b. And the directions are saying rewrite this as a number given that log of a equals 2. So see, I don't have log of a right here. This is actually log of a to the 4th. And this is log of b squared. All right, so I replaced log of a with what it's equal to 2, and log of b with what it's equal to, which is 3. 4 times 2 is 8. 2 times 3 is 6. So 8 plus 6 is 14. All right, I hope this video helped you. I wish you your best on your test this week. Thanks for watching us.